Hello students. So let we begin the third part of this first unit. It is nothing but the problem solving sessions. So let me go through it. So in this video we are going to see about double acting cylinder. So in the case of double acting cylinder, how to calculate the area. So if it is a double acting cylinder, the pressure will be acting on this side as well as this side. So when it is going the pressure acting on this side, it is P1, which is multiplied by the area A1. So it is the full pressure. You can able to see this here. The area is this one, A1 pi by 4 capital D square. So it is A1 is nothing but pi by 4 D square. It is bore diameter. When it is coming to this side, it is going to be the area which is to be subtracted from small a. So that is A2 is nothing but the area A1 minus A. So this is the A2. A1 is already this one. A is nothing but pi by 4 D square, where D is nothing but the piston rod diameter. So with this introduction, we can able to solve the problem. So in this video, we are going to see the very first problem, that is your vertical double acting steam engine. So the given vertical double acting steam engine, they are giving that the cylinder diameter is 300 mm, then 450 mm stroke length. That is nothing but you can able to see it is converted into radius L by 2. So it is radius of the crank is 0.225 meter, runs at 200 rpm. So you can able to calculate omega 2 pi n by 60. The reciprocating parts mass is given as 225 kg. The piston rod 50 mm diameter small d. The connecting rod length is 1.2 meter. When the crank has turned 125 degree, we are going to calculate the effective turning moment on the crankshaft. So for that, they are also indicated that the pressure is going to be acting on both the sides. So the left above the piston is 30 kN per meter square. Below the piston it is 1.5 kN per meter square. So it is a double acting engine. We have to calculate the net pressure. Okay, otherwise the force acting on the cylinder is going to be calculated based on the two sides of the pressure. So let me calculate area first. So if you are calculating this area, the pressure acting on the top side is P1, okay, above, and below it is going to be P2. So here the area is A1, here the area is A2. What is A2? A2 is nothing but A1 minus A. So first we calculate A1. It is nothing but pi by 4 bore diameter. So pi by 4 into D square. So here it is 0.3 meter. You can substitute. So the 0.3 meter, if you are substituting it, you will get the answer 0.07 meter square. Similarly, I am substituting the piston rod diameter pi by 4 into 0.05 square. So which is comes around, after calculation, 0.000196 meter square. So next we will calculate what is FL. So here the next we are going to calculate load acting on the piston. Okay, so we are going to see what is going to be the net effective piston effort. Okay, for that we are calculating FL first, then inertia force, then we will subtract it, so we will get the FP. Okay, so in that case, so let me see that. So the force on the piston due to steam pressure is pressure 1, which is given, pressure on the above and pressure on the bottom side. So the given pressure, if you are substituting it, which is P1 is 30 into 10 power 3 . Okay, now it is going to be area which is calculated in the previous side is 0.0707 minus, then it is same thing, pressure is given as 1.5 into 10 power 3. Okay, then same A1 you have to substitute 0.0707 minus is going to be 0.00196. So using calculator, if you are calculating, I am getting the FL equal to 2018 Newton. So next thing is I have to calculate inertia forces, isn't that? So for that I need the ratio of this connecting rod to crank. It is going to be N equal to L by R. So if I am substituting it N equal to L by R, I am getting N as L is 1.2 divided by the crank radius in meter 0.0225, which comes around 5.33. Now we can go for this inertia force calculation. Mass of the reciprocating parts is given, which is 225 into omega we calculated in the given data, that is 20.95 square, then 0.225, then I am writing it here, cos theta value is given, is it not? It is 20 degree, so we can write 20 degree, sorry, it is going to be 125 degree plus cos 2 theta, okay, 2 into 125, so it is degree, divided by whole divided by n. N is 5.33. So on calculator, if you are putting this, calculating it and getting the answer, it is in the form of negative minus 14.172 Newton. From the calculator I am writing this. Okay, in this what is happening, this inertia force is negative. Already it is going to be FP equal to FL minus inertia. Now it is negative, so then it will become as positive. Okay, so minus of minus positive. Why it is became negative? Actually, if it is 20 degree means the piston is moving from top to bottom. But when it is come to around 125 degree, then it is goes on for deceleration. So if it is deceleration, inertia force is aiding the piston load acting on the piston. So it is comes as positive. Automatically it is coming as the positive. So what we have to do, just substitute the values whatever we got it. So it is 2018 minus of minus, so 14.172 plus mass of the reciprocating parts is given as 225, then 9.81. So this value if we are calculating, which is going to be comes around 18,397 Newton. So this is our FP. So if the FP is known to us, then we can able to easily calculate the torque. Is it not? Okay, so we have to calculate FT. After FT, we can able to calculate the torque. So this is the value. Okay, 18,397. Next, we will calculate the torque. So the last thing we are going to calculate the torque. If I want to calculate the torque, I have to calculate FQ, then FT. So in that case, I need to know what is going to be the pi. So what we are going to do, so these are the formulas. If I know the FP, I can calculate FQ. Similarly, if I know the FQ, I can calculate the FT. Okay. So last one is FT into R. So in that case, we know sin phi equal to sin theta by n. So the sin theta is nothing but theta value is 125. So if you are giving sin 125 divided by n, n is nothing but your 5.33. So we are getting pi equal to 8.84. So I am substituting the known values of FP. FP is 18,397 divided by cos 8.84. So while calculating, the answer is 18,618 Newton. I am substituting this FQ here, 18,618. Then the known values of theta and pi, 125 plus 8.84. After calculation, I am getting it is 13 kilonewton, 13.43 kilonewton. Otherwise, I am getting it as 13,435 Newton. So this one I am substituting it here, 13,435 into the radius of the crank is given as 0.225. So now this multiplication gives us the torque which is produced. The given vertical double acting cylinder is 3022 Newton. So the next problem also we are going to talk about this vertical engine only. In this case, okay, so here the vertical petrol engine, 100 mm door diameter, 120 mm stroke, has a connecting rod 120 mm long. The mass of the piston is 1.6 kg. Okay, so here reciprocating pass. The speed is 2000 rpm. We are going to convert this into omega, which comes around 209.5 radians per second square. So on the expansion stroke, so you see that it's very less, 20 degree only. Here definitely the inertia force will be positive, but we will put it as negative. Okay, so the net force on the piston we have to calculate first. It is nothing but Fp. So we have to calculate load acting on the piston, inertia force, weight of the reciprocating parts. Then we will go for resultant load on the gudgeon pin. Okay, so that is going to be your Fq, thrust on the cylinder walls. Then speed above which the gudgeon pin load would be reversed this direction. What is the meaning of this? It is actually rotating like this. If it is to be reversed, then what is the meaning? This speed has to be reversed. What is the meaning? Means this inertia force has to be, now it is positive. Now if it is comes as negative, that is the meaning. In the previous problem also we told. So whenever the inertia force is going to be positive, negative value, from the positive to negative it changes, it also directly implying that the piston is changing its direction. So simply definitely till 90 degree, if the crank angle is till 90 degree, definitely the inertia force will be positive. After that, what is going to be happen means the inertia force will be net negative. That means most of the cases the inertia force negative instance, so we are getting that the gudgeon pin will be reversed in direction. So we substitute that and get the speed at which the gudgeon pin is reversing its direction. So the next thing we solve it. So the first thing we are going to calculate net force on the piston. So Fp equal to Fl minus inertia force plus weight of the reciprocating force. So I am calculating force due to gas pressure into pi by 4 d square. Substituting the given values, pressure is 700 Newton per meter square. Then now it is going to be d bore diameter. Substitute it. What we are getting? We are getting the value 5500 Newton. Now calculate inertia force. Mass of the reciprocating parts, theta is given, n equal to L by R. So L by R you can substitute, we get 4.7. So 1.1 is the mass of the reciprocating parts. Omega is 209.5. Radius is 0.06. Theta is 20 degree. N is 4.7. If you are substituting, I am getting the value 3254 Newton. So the net force on the piston is Fl minus inertia plus Wr. Wr is very simple. It is mass into gravity. If I am substituting it, I am getting 2256.8 Newton. The resultant load on the gudgeon pin is nothing but our Fq. So I calculate pi. Okay, then I substitute it here. So it is pi is comes around 4.7. So Fp we know it is going to be 22568, just like that I am substituting it here. Okay, so now the calculated value of Fq is 2265 Newton. Now the third important thing is thrust on the cylinder walls, that is the normal force. Okay, F1. So you substitute Fp, same 22568.8 into tan phi. So we will get the value around 185.5 Newton. The last one we see it in the next slide. So this is the main important calculation which is differs from the previous problem. Is we are calculating the speed at which the crank is reverses its direction. Actually it is implying. So when this crank is to be reversed, Fq to be negative. When the Fq should to be negative means the Fp is to be negative, because Fp and Fq are directly related. Okay, so Fp is to be negative means then Fl plus W, this is to be greater than the inertia force. So okay, sorry, inertia force is going to be greater than the Fl plus. So what will happen? Inertia forces become the dominant one. Okay, in that case, substitute the inertia formula. Here previously we substituted the given omega. Now you should calculate it. That is the only difference. Okay, remaining all the things is same. So you are going to calculate omega. Okay, so substitute theta. Okay, omega you are calculating step by step. You are solving it. The last stage, the omega, we are deriving it as 273 radians per second. Since they are asking speed, it may be angular velocity. Otherwise, the speed we can directly given in the form of RPM. So we are considering speed in RPM. Substitute omega equal to pi n by 60. Otherwise, n equal to 273 into 60 divided by 2 pi. Calculating this, I am getting the value 2606 RPM. This is the speed at which the Gaussian pin load reversed in direction. So with this, we have completed 3 problems in this unit. The next very important problem, we are going to proceed with the petrol engine or diesel engine. So maybe the diesel engine, let me take. Okay, from that we will solve it.